Let's do another example of the definite integral. Was the substitution rule. So let's say we need to evaluate the integral 3 minus 5x in the square. X changes from 1 to the 2. Okay? So it would be indefinite. You need to do substitution of 3 minus 5x. Right? So let's do this in two ways. The first way is we will substitute everything, we integrate everything, then at the end we'll resubstitute, then evaluate the integration, okay, the real value. And the second way is when we substitute the x with a u, we will immediately substitute the borders of the integration. Okay? So the first way is like u is equal to 3 minus 5x, right? So what is the du? du is the differentiation of this part. What is the du? Minus 5 dx, right? So in order to substitute everything in this integration, you have to somehow include here minus 5, right? Because it should be minus 5 dx, right? Since you're multiplying your integration to the minus 5, you have to divide this to the minus 5 as well, right? Do you understand this? So in order to substitute du with the minus 5 dx, you have to make it minus 5 dx, right? Okay, so this will be integration minus 1 over 5 of the integration du divided to the u in the square, right? So what is the antiderivative of the u in the square? It is u in the power of minus 2 plus 1 divided minus 2 plus 1, right? So this will be equal to 1 over 5 u in the power of minus 1, okay? Since this is the definite integral, you need to tell me the number at the end, right? Not a function. So it means that you need to resubstitute back your previous old variable with the x, and you have to evaluate the function at the borders of the integration, okay? So this is equal to 1 over 5 multiplied to the 1 divided to the 3 minus 5x, right? Because u in the power of minus 1 is 1 over u, right? So since u is equal to the 3 minus 5x, it will be 1 over 3 minus 5x, right? We need to evaluate this at the 1 and at the 2, okay? So this is 1 over 5 multiplied to the 1 divided to the 3 minus, what is the 5 multiplied to the 2? 10, right? Minus 1 over 5 multiplied to the 1 divided to the 3 minus 5 multiplied to the 1 is 5, right? So this is 7. 7 multiplied to the 5 is minus 1 over 35, right? So this is minus 2 multiplied to the 5 is plus 1 over 10. Okay? Yes? So this is the first way. The second way is if you decide to change the variable x with the u, so minus 5x, 3 minus 5x in a square, x changes from 1 to the 2. With the u, minus 1 over 5 of the integration du divided to the u square, we can change the borders right immediately. Okay? If the u is equal to 3 minus 5x, right? What will be the value of the u if the x is equal to the 2? If the x is equal to the 2, oh, just wait a moment. So it was like this, right? So if the x is equal to the 2, what will be the value of the u? So you have to put this x to be equal to the 2 to here, right? It will be minus 7, okay? Minus 7. Do you understand this? If the x is equal to the 1, what will be the value of the u? Minus 2, okay? So you can immediately change the borders of the integration as well, okay? Either you do this at the end by resubstituting, either you do this immediately. So this will be equal to minus 1 over 5, or u in the power of minus 2 plus 1 divided to the minus 2 plus 1. We need to put the values minus 2 in minus 7. Okay? So this will be equal to 1 over 5 multiplied to the u 1 over minus 7 minus 1 over 5 multiplied as the 1 over minus 2, right? So the answer will be again minus 1 over 35 plus 1 over 10. Okay, the same answer. Do you understand this? So the substitution rule works a little bit differently if you have the definite integral. Okay, so if you have the definite integral, you have to make sure that you are substituting the borders of the integration as well. Okay.